Are you there? Let me know.
Hello, sir.
Yeah. Yeah.
Yes, sir. Can you hear me now?
Yeah, I can.
Yeah.
Okay, all right. Okay, am I audible now?
Yes, sir.
Screen is visible? Yeah, okay, all right. Okay.
Uh,
First, I'm just
quickly help you with this revision. Atomic structure we have just completed. We just came to know that atomic structure has a very interesting fact that they are not very small, but even smaller particle, subatomic particle exist inside those atoms. Uh, those are proton, neutron, and electron. We also completed states of matter, and the size of atom is in the range of picometer, angstrom. In 1 angstrom, there are 10 to the power minus 10 meter, and its size is about 100 picometer. And in 1 picometer, we have 10 to the power minus 12 meter. And we just came to know about those 5 states of matter. The prominent of them is initial 3, solid, liquid, and gas. Then we covered the definition of atom. It is actually the meaning of atom is actually indivisible, and Dalton has also given their postulate that suggests that it is indivisible. But actual definition goes like this: it is not in fact indivisible. It can be further divisible, but it is one of the smallest identifiable unit of an element. Then we covered about proton, neutron, and electron in much detail, and we just came to know that proton and neutron are there at center and comprise of the entire mass of the atom. And we also came to know about number of electrons. And when we use this postulate of number of electrons, we consider Bohr models of the atom in our consideration. I'm just going to help you with that model. But before, I want you to know about proton, neutron, and electron with the charge and masses. Charge is same for proton and electron, but zero for neutron. The charge is 1.6 into 10 to the power minus 19 coulomb for proton, and same amount with the negative sign is there for electron. Masses is about very negligible, but for proton and neutron it is in the range of minus 27, but for electron it is in the range of minus 31. That is why I say it is negligible. Electron's charge is even very negligible as compared to that of proton and neutron. That is why the charge that is there with an atom is due to proton and neutron only. The charge that we have for an atom is due to proton and neutron only. That mass and this is known as atomic mass. And this proton is equal to atomic number as well. And for a neutral atom, the number of proton and number of electrons are actually equal. Okay. Then we consider who discovered them. Rutherford discovered proton, James Chadwick discovered neutron, and J.J. Thomson discovered electron. You can also go through their masses, the exact value, and you can just conclude that neutron has the greatest mass and proton has the midway, and electron is the least, or you can say lightweight out of these three, the lightest particle. And then we have the definition of an atom, an element, a molecule, a compound that we covered. We just went through this. Then we came to know about elements and their elements and their number. Okay. We just came to know that there are 118 elements in which 93 are metals and 7 are metalloid and 18 are non-metal. And we just consider their arrangement in modern periodic table. Actually, in this periodic table as well, there were many scientists who tried to arrange these elements. And nowadays, the particular arrangement that we follow is modern periodic table, in which you can just observe S block, initial two column, that is group 1 and group 2. And then we have D block, and here 13, 14, 15, 16, 17 and 18. These columns are, you should say, groups are actually your P block, and the below two rows are actually lanthanides and actinides, which are F block. And then we just learned these 20 elements with their atomic number 1 to 20: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, and then we have aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. We also came to know about some of the properties like number of neutrons, and based on number of neutrons and number of protons and number of electrons, we also came to know about isotopes and isobars. In isotopes and isobars, can you just tell me what is difference in these two? Sanket, I want answer from your side. Difference between isotopes and isobars with one example. Tell me difference between isotopes and isobars with an example. Very interesting thing. Many times you get such a question. In all type of exams, we get questions from isotopes and isobars. Sanket, please tell me.
Yes, sir. One second. Yeah, sir. So isobars are like elements that differ in chemical properties and also have like same physical properties. So isobar are like elements, they have different atomic number but have the same mass number, and isotopes are those elements which have same atomic number and different mass numbers.
Very good. Same atomic number but different mass number. It is one of the very interesting points. Same mass number here. That means same A, I should say, and different same atomic number, that is same Z, I should say, and different mass number, that is different A, I should say. Here same mass number and different atomic number Z is here. And the second thing that you said is in isobars they have different chemical properties, isn't it?
Yeah.
And what else? Here chemical properties are same.
Yeah. And
what else? Tell me.
Yeah, different chemical properties and same physical property. Yeah.
In case of isobars, same physical property you will observe.
And then isotopes are different physical property.
different physical
property you will observe.
Yeah.
Okay, can you tell me some examples of both of them?
Okay, wait.
Here
We have famous example carbon 6C12, 6C13, 6C14. This third one is very interesting. Can you tell me the important things about this
third
third
isotope
isotope of carbon? Some of the property of this third isotope of carbon. Carbon 14 we say it in normal form. We call it carbon 14 in general. What are different properties that we have
for
this carbon 14 isotope of the carbon?
I have
I have explained this in previous class as well.
Tell
Tell any one or two properties that you know. Similarly, we have some of the isotopes of hydrogen as well that are also very interesting. Going to be 1H1 we have, 1H2 we have, 1H3 we have.
These are
protium, deuterium and tritium. They are very interesting. They are going to combine
these
deuterium combine to form helium.
And
these reactions
known as nuclear fusion. And such reactions, nuclear fusion, occur there on the
surface of sun.
And this is the reason of sun being this much hot. The temperature on the sun's surface is somehow 6,000, 1,500 to 6,000 degrees Celsius. It varies, and it is due to these nuclear fusion reaction that occur there in sun. Okay, this is important about this protium. I said I asked you to tell me about this carbon 14. Okay, I'm telling you that this is radioactive, the first thing. The radioactive isotope. The second thing is we use it for carbon dating. Can you tell me what is carbon dating?
Carbon dating is a technology or branch of science in which we use these radioactive material to figure out ages of old objects on the basis of carbon and its decaying state, carbon's decaying state. Because radioactive substances have a very interesting
thing.
What is that interesting thing? Their half-life.
And using that half-life concept, we figure out ages of civilizations.
Like
we have
Indus Valley civilization. Have you heard of this?
Yes, sir.
You must have heard this in your social science. We figure out the age of this Indus Valley civilization varying from 2350 BC to 1750 BC. This civilization was between this era. We figured out it using this carbon dating and carbon 14 isotope. That means it is used to figure out ages of old objects, maybe any civilization, maybe any fossil, maybe any monuments, maybe any excavated objects.
And here
isobars,
some example of
isobar, do you know?
One of the example of isobar that
you
should understand here. No, it's actually, if you remember, I have explained those 20 elements, and these are here. I have explained these 20 elements. In these 20 elements, I've indicated that argon also has atomic mass 40,
and this calcium also has atomic mass 40. And we also understood the definition that argon can be written as 18 Ar 40, and this can be written as 20 Ca 40. They have different atomic numbers, but they have approximately same atomic mass. That is why we call them isobars. What are the example then? We have argon and we have calcium that we consider here as isobar because they have same atomic mass. Got it?
Yes, sir.
And then we just covered the models, different models of atoms by using which we can convey about the structure. One of them is Dalton's atomic model. Then we have Thomson, then Rutherford, and then Bohr. The latest model that we follow today is Bohr's atomic model, which is a bit modification of Rutherford atomic model. What does these models suggest? They were the step-by-step progress about atomic structure. Earlier, Dalton suggested some postulates in which he concluded about atom being indivisible, which was proven to be wrong. Thomson suggested that negative and positive particles are along a sphere like a watermelon. These seeds we have as electrons, and this eatable part we have as proton, but it was also not true. Rutherford suggested the true thing, that actually the mass is entirely concentrated at center due to proton and neutron, and electrons revolve around
And as per this, we know today that center has the entire mass, which is due to proton and neutron, and electron revolve around the center. But they have not told anything about the stability, which was explained by Bohr, and he suggested how electrons revolve around atom, and what is number of electrons in different orbits. It's 2n square, and maximum number of electrons that can reside in any orbit can be figured out using this formula. Then we have valence and valency. Valence is the number of electron in last orbit, that is known as valence electron, and valency is the combining power. Okay, combining power. And then cation and anion. Cation is formed due to loss of electron, it is positive charged ion. Anion is formed due to gain of electron, it is negative charged ion. Then we have just understood different cation and anion, and also understood how to frame any formula, and we have designed many formula. Then at last we have just started molar mass. And also temperature conversion we covered in previous classes, and we have solved these important MCQs as well. Then a bit about matter being pure and mixture. There, pure has again element and compound in two categories. Mixture has homogeneous and heterogeneous. And then we covered the molecular formula as well. And these questions. Then we started molar mass. We came to know how to figure out molar mass. Like this, if I have a compound like CCl2F2 and we want to figure out its molar mass, the answer is given. I'm just telling how will we arrange this. Carbon atom, one carbon, then chlorine, there are two chlorine atoms, then we have two fluorine atoms. Now I will let you know that carbon is 6. 12. We generally consider 12 mass, not the other isotopes here. Similarly, for chlorine, that is 17 atomic number, the mass we consider is 35.5. And similarly with fluorine, I will just tell you
above I have
the entire,
this is
yeah, this is the entire periodic table where I have mentioned all the masses. You can just see fluorine. Fluorine is 9. It's about 19, 18.998, which is approximately equal to 19. That means it is 9, 19. Okay, I'm just putting all these masses in the place. Here C means 1C, that means 1 times 12. Chlorine has the mass number 35.5, I will write. Fluorine has the mass number 19, that I will write. Then I will multiply here. It's going to be 71. Then I will multiply here. And in this way, I will now add all of them and I will get this. It's going to be 11. It's 121 gram. And when we consider this compound, it is considered to be 1 mole of this compound. In 1 mole, this much mass is there. Now, there is a word mole used. That's why I'm telling you the interesting thing about mole. Okay. What is interesting thing about mole? Actually, the number of atom or number of ion present in molecular mass. Present in molecular mass of any substance. If I'm considering H2O, hydrogen has the mass 1, oxygen has the mass 16, it is going to be 18 gram. In 18 gram of H2O, there will be 1 mole. Okay. And I just want you to understand this thing, that in 1 mole, how many elements are there? In 1 mole of any substance, there are Avogadro number elements. That means 6.022 into 10 to the power 23 elements. 6.022 into 10 to the power 23 elements. This is known as Avogadro number. Elements present in any 1 mole. In 1 mole, this much elements are there. And that is why if you want to figure out number of mole anytime, you can use this formula. Number of mole is equal to given mass divided by molar mass, or you can use the formula given number of element divided by Avogadro number. These formulas are used to figure out number of mass. Let's say I'm given with 54 gram of H2O, and I want you to tell me how many moles are here. Can you tell me? In 54 gram of water, how many moles are there? How many moles are there? Yeah, this is new topic actually. Molar concept is a new topic. Mole concept, I should say. And before we start with this mole concept, we must know how to find out molar mass. That is why I have first told you how to find out molar mass and molecule mass. Okay, we just need to know the mass number of all of those elements involved there, and then we can just figure out molar mass. Right now I have asked a question that I have just given you the formula that given mass divided by molar mass. This is given mass. And this is molar mass. Formula to find out number of mole, and it is also equal to given number of element divided by Avogadro number. In any atom, in any 1 mole atom, I should say, how many atom are there? How many atom are there? 6.022 into 10 to the power 23. This number is, this constant is Avogadro number actually. Got it? And my question is how many moles are in 54 gram of water. Can you tell me this? First I will tell you molar mass of water. What is the molar mass?
Water is actually
H2O. I've already told you that two hydrogen
and
and one oxygen.
That
That means
2 times
2
1
times 1
plus
plus oxygen is actually 1 times 16. That is going to be 16 plus 2. 18 gram is the mass of
molar
molar
mass
mass of
H2O.
H2O.
Now,
Now,
formula is
given mass divided by molar mass.
Given
Given mass is 54, molar mass is
18.
18. Can you now tell me how many moles are here?
So 3.
3
3 moles of water give you 54 gram of water. Is it clear to you?
Got it?
Got it?
Yeah.
This is a new topic. You put this there in your.
Okay,
This is also a new one, but I think I have given bit idea about molar mass in previous class as well. Because I helped you to find out molar mass of this compound C6H12O6. Do you know the formula of this C6H12O6? How many molecules, I should ask like this, how many first you tell me how many moles are in 900 gram of
right
here 900 gram of
glucose. Okay.
I have framed this question for you.
Okay.
I will tell you what is this glucose and for what I have used this. Glucose here means this compound C6H12O6, and as per the question I'm given with, given mass is there, that is 900 gram. Small m, I mean given mass. And I want you to tell me number of moles.
What
will you do here to figure out the number of moles?
First you
will find out molar mass.
What will
you do, Sanket?
Find the molar mass.
First you will find
molar mass. How will you find that?
If you want
to find out the molar mass, what will you do? You will figure out how many carbon are here.
6
carbon are here.
You
will figure out how many hydrogens are there.
12
hydrogens are there.
You
will figure out how many oxygens are there.
6
oxygens are there.
In spite of this,
you need to know what is the
atomic
mass of this carbon.
You need
to know what is the atomic mass of this hydrogen.
You
need to know what is the atomic mass of this oxygen. We know that 12 is the mass of carbon, 1 is the mass of hydrogen, and 16 gram in the gram mass is with oxygen. We will put this carbon in the place of carbon, we will put its mass. In place of hydrogen, we will put its mass. In the place of oxygen, we will put 16. And in this way, we got 72 and then 12 and then 96. Now we need to add them all. 6 to 8 to 10 and 9, 1, 10, 17 and 118. 180 gram is the mass, molar mass in gram. Now, do you know the formula to find out number of mole?
Yes, sir.
What it is?
Given mass
divided by the molar mass.
Divided
by molar mass. In abbreviation, we use the formula like this. Small m over capital M. Small m is given mass. Capital M is the molar mass. Given mass is 900 and molar mass is 180. We can cancel out this 0. Further, 18 table of 18. How many times?
So the answer is 5.
Yeah,
exactly. 18 5s are 90 actually. 5 moles.
What does
it mean? 5 moles of glucose
has the
mass 900 gram.
Is it
now clear to you?
Yes, sir.
Yeah.
Is it now clear what is this mole concept? Can you solve the question based on mole concept? You only need to remember these two formula. These two. Okay.
Now
Now the next question
from this
from this
question,
question,
I'm framing
I'm framing one more question.
I'm
I'm
including
including one more
question
question
here.
here.
I want
I
you to
want
tell
you to
me
tell me
next
question, that is
how
how
many
many
particles
particles
are
are
in
in
how
how
many
many
particles are
particles
in
are in
900
900
gram of
gram of
how many
how many
glucose
glucose
particles are in
particles are in
900 gram
900
of
gram of
glucose
glucose
powder.
powder.
Okay, how
Okay,
many
how many
particles are?
particles are?
I
I
have
have
already
already
told
told
you
you
that the
that
number
the
of
number of
moles are
moles are
5
5
moles.
moles.
In
In
180 grams
180
there are
grams, there
5
are
moles.
5 moles.
And we
And
know
we
the
know the
thing
thing
that
that
in one
in one
mole,
mole,
in one
in
mole,
one mole,
number of
number of
particles.
particles.
How
Do you
many
know how many
particles are there
particles
in
are
one
there in
mole?
1 mole?
It's
It's
n naught.
n naught.
Actually, one
Actually,
more
one more
formula is
formula is
n over
n
n
over
naught.
n naught.
N is the
N
number
is the
of
number of particle and naught is the
number of
number of
particle
particle
in
in
one
one
mole,
mole, that
that is
is
6.022
6.022
into 10 to
into
the
10 to
power
the power
23.
23.
In
In
each
each,
in
in
any of the
any of the
particle,
particle, in any of the atom, any of the
any of
element,
the
any of the
molecule,
molecule,
if it is
if it is
one mole,
one
the
mole,
number
the
of
number of
particle
particle
presents, the number
presents,
of
the number
ion
of
present,
ion
the number of
present, the number of
atom present,
atom present,
whatever it is.
whatever
If it
it
is
is. If it is
atom, we
atom,
will
we will
consider number
consider
of
number
atom.
of atom. If it is
We
molecule,
will say
we will
number
say
of
number of
molecule. If
molecule.
it is
If it is
ion, we
ion,
will say
we will
number
say
of
number
ion.
of ion. In
Mole of
one mole of any atom, molecule, ion or
the
compound, the
particles are this
particles are
much.
this much.
And that is
And that
why
is why we will put,
we will say that 5
5 n is equal to here V1,
and not is
and
actually
not is actually
6.022 into
6.022
10 to the
into 10
power
to the power
23.
23.
That means
That
number
means
of
number of
particle
particle is how much?
5 times
5 times 6.022
into 10
into 10 to the power
23. We
23.
can
We
further
can
solve
further
this.
solve this.
5 to the 10,
5 to the 10, 5 to the 10 and 11.
And
And
here
here we got 5 6 are 30 into 10 to the power 23. And that means 3.011 into 10 to the power 24 particles of glucose are present
in
in
5
5
moles
moles
of
of
glucose.
glucose.
You got
You
this?
got this?
Yes, sir.
Okay, very
Okay,
good.
very
Now
good.
tell me
One more question.
I want
I want you to answer me. The first is
how many
how many how many particles are present in, how many particles of CO2 are present in are present in 1 minute. 260 gram of CO2. This is a new question for you. One of the important one. I want you to answer this one. How many particles are present in? How many particles of CO2 are present in 260 gram of CO2?
How many particles?
Yeah.
How many
particles of CO2 are present in 264 gram of CO2? Is this topic there in your syllabus? You figured out it?
Sir, I don't think so. Wait, 1 second, sir. Let me check the unit letter.
Yeah, you can check, but because maybe they are in your higher class, if not now. That is why I want you to clear this. But this is going to be very helpful later on as well. You just isotope and isobar must be there.
I think so.
Structure of
I'm not sure, sir. Let me check.
Yeah. You do that. This hydrogen sulfide, making compound may be there.
Okay, all right.
Okay, all right. This is
one of the
important thing.
Extra topic
You must be there in your mind. You must
know
know what
these
these mole
means.
means.
That is
That
okay,
is okay, even if it is not there in your
syllabus.
syllabus. It's okay.
You tell me
You
the
tell me
answer
the
to
answer to this one, then we will
start
start with
with
something else, something new.
How many
How many particles of CO2 are present in 264 gram of CO2?
Can you
Can you answer this? First, what will we do?
We
We are given with the
mass
mass that is 264 gram,
and we
and we want a molar mass that is there are one carbon, there are two oxygen. That is why this is 1 times 12 and this is 2 times oxygen. It is that is 16. It's coming out to be 12 plus 32. That is 44 gram. It is molar mass. Number of mole now we want is small m over capital
So
M.
that means
That is going to
264
be
divided by 44.
exactly. It's 6 times. We got the number of moles equal to 6 moles. Now capital N is equal to small n times n naught, because we know the formula small n is equal to small m over capital M, as well as it is n over n naught. Now we want n, that means it is going to be small n times n naught. Here we are using this, and 6 times the value of n naught is 6.022 times 10 to the power 23. That is coming out to be 36.132 and times 10 to the power 23. It's coming out to be 3.6132 times 10 to the power 24. Particles of CO2 are going to be there in 264 gram of CO2. Is it okay for you?
Yes, sir.
I think
you will be able to solve all these questions. Do you want some question there in your homework based on this mole concept? And then we can start with some new topic if you want.
Yes, so we can
Which
start
topic
with
you
a
want?
new topic.
Yeah,
Because
we have,
speed, time and distance, probably.
we can do with that. We can go with the speed, time, speed, distance, and time, no issue. And I will start with that. You don't worry. Do you want some questions from mole concept as your homework?
Sir, I don't think we're gonna do mole concept in
it's okay.
It's